Okay, in the last video we looked at how to graph y equals log base 2 and y equals log base 3. So that gives you kind of an introductory look at actually graphing, points and finding the asymptote and things like that. So if we look at them again but together, let's say that we look at log base 2. So remember it crossed at 1, 0, 2, 1, 4, 2, 8, 3, and so on. It kept getting bigger and bigger that way. And as we got closer to 0, it came down closer to 0 that way, and we had an asymptote at 0. Okay, so that's what y equals log base 2 looks like. If we look at y equals log base 3, it is also going to cross at 1, 0. And it went 3, 1, 9, 2, and 1, 3, negative 1, and so on like that. Alright, so that's log base 3, and this one is log base 2. Now we can take what we know about this and what we know about exponential functions, and we can probably predict what log base 4 is going to look like. So remember, for exponential functions, the bigger the base, the steeper it got. Well, the same idea with logarithms. If we wanted to graph log base 4, it would also cross at 1, 0, and it would get steeper. So it would come under here like this, and then it would get flatter towards the asymptote like this. Okay, so there's log base 4 of x. Now remember, so we did, let's write that down, y equals log base 4 of x. Now there's one other logarithm that we see quite a bit, and that is y equals ln x. Okay, remember ln x. Remember that natural log is base e, and remember that e is between 2 and 3. So if we wanted to graph natural log of x, we could squeeze that in here between 2 and 3. It'd be a little bit closer to 3, but not really enough to be able to measure. Okay, like that. So that would be ln x. Okay, so ln would be between 2 and 3. Now if we had to graph and plot points, 2 and 3 would be easier, but if you want to use your calculator, the natural log is actually easier. Log base 2, log base 3, log base 4, some calculators can't even do that, and the ones that can, they're kind of a pain to get to. So what you can do is you can always use y equals ln x as just approximation of the shape, and then realize that the different bases will just be a little bit more steeper. Like the higher the base, the more L shape it's going to be. The lower the base, the more curved, gradual it's going to be. Okay, but you can use your calculator to kind of get an idea of what the picture is with ln x. Okay, so let's look at some transformations. Now that we see the basic graph here, okay, this is the basic natural log graph. Let's do some variations on this. So let's take all of this. Okay, let's start a new graph. Let's go ahead and write up, we're going to call this log base a of x, just as our generic graph. And our key points for this are the asymptote and the fact that it crosses at 1, 0. Okay, so it goes up on the right, down on the left. Okay, so that's our general picture. So now if we want to graph some variations on this, let's say that we want to do y equals log base 3x plus 5. Okay, so log base 3x, it looks like this. Okay, that's our basic graph. And the plus 5 is on the outside of this graph. Here, let's do y equals ln x plus 2 next. All right, we're going to do this one next. This is the comparison to know whether it's inside or outside the function. If there are no parentheses, it is not inside the logarithm, kind of like a square root. Okay, square root of x plus 5 versus square root of x plus 5. Okay, this one is in the function, this one is not in the function. Same idea here. If it has parentheses around it, it's inside. If there are no parentheses, it is not part of that logarithm. Okay, so this one is outside, and we know that that means that we're going to shift up 5. So we're going to take our basic logarithm graph. Shifting up 5 is not going to change our asymptote. Our asymptote is going to stay along the y-axis. Okay, now our crossing point was here, but we're shifting up 5. 1, 2, 3, 4, 5. Now we've got the point here at 1, 5, and we're going to go down on the left and up on the right. Okay, so similar to the exponential functions, if you just plug this in your calculator, it's pretty hard to see what's going on. You're not going to see the asymptote, and none of these points are going to be distinct. So you kind of have to know what's going on and know what's happening to the points to get a decent picture for it. Okay, next one, natural log of x plus 2. You see natural log and you think, okay, it looks like this. It's about the same as log 2 or log 3. So natural log of x plus 2. Now this time the 2 is inside, okay, inside the parentheses, inside the function. That takes us left or right, and it's going to be opposite. So it's going to take us to the left by 2. And just like with the exponential function, that doesn't mean the graph goes to 2. We're actually going to shift the asymptote first. The asymptote is at 0, 0. So when we go left by 2, we're going to shift the asymptote. And then the graph is going to cross 1 to the right of that. And it's going to go up on the right, and it's going to go down on the left. Okay, so just like with the exponential function, we're going to shift the asymptote first, and then this point at 1, 0, we're going to shift up, down, left, or right. Okay, let's try just a couple more. Make sure that we have the right idea here. Remember that basic log graph as we go on. All right, let's say that we've got y equals log of x minus 4. Okay, log of x minus 4. So the first thing that you remember when you don't see a base here, remember that this is common log. That's base 10. Common log actually is in your calculator. You could actually plug this in your calculator and look at it. Log base 10 is the log that's on there. But it doesn't matter because it's still our basic shape. The higher the base, the steeper it is. So it's going to be a little bit more L-shaped than our one on the right here. This one's pretty rounded. Ours is going to be more L-shaped. And the minus 4 is on the inside the function. So that's going to tell us to shift right. Shift right by 4. Okay, so we're going to go 1, 2, 3, 4. Now that's not where our graph is. That's where our asymptote is. Okay, so we shift the asymptote first. And then the graph is going to cross 1 to the right of that. And it's going to go up to the right, but steep, because it's a 10. And it's going to go down to the left, steeply like that. Okay, so it's going to be a little bit more L-shaped than our natural log graph. But again, that's kind of, you know, as long as you get the general idea of what it looks like, you're good. All right, let's do one more. Well, it didn't grab everything, did it? Let's try that again. This is a new drawing app for me because the old one kept going crazy on me. Apparently this one goes a little crazy too. All right, let's try one more to finish this out. Let's do y equals, let's see, we did left, right, okay, so let's say we have y equals log base 5 of x minus 3. Okay, just like with all of these functions, the first thing you ask yourself is this inside or outside the function? There are no parentheses, okay? It'd have to look like that if it was inside the function, but we don't have that. So that means that the log only goes with the x, not with the -3. And so that tells us it's outside, and we're going to shift down 3. Okay, up and down don't affect the asymptote, so the asymptote stays on the y-axis. We would have crossed 1 to the right of that, but we're going to shift down 3 to there. So we're going to have 1, -3. And from there, we're going to go up to the right and down to the left. We've got a base of 5, so it's not going to be quite as sharp as the base 10. It's not going to be quite as smooth as the base 2, kind of in between. All right, so base 5 will be kind of in the middle. So you can see we're kind of L-shaped, but not as sharp as the 10. Okay, so that's the basic idea. You move up, down, left, right. Make sure that you move the asymptote first, and then the log will cross 1 to the right of that.